Hello, great mind. Welcome to my YouTube channel, Focus Academic Solution. Today, I'll be talking about preparation for 2023 JAM, that's physics to be precise, but I'll be dealing with projectile motion and the derivation of projectile motion and its calculation. And if it is the first time of viewing my YouTube channel, click the subscribe button and press the bell to see more of my videos. Thanks. Okay, from this diagram, we can explain the terminologies used in solving projectile motion. Now, if you look at this diagram very well, you can see from the diagram I'm having my maximum height of the projectile, and which means that's the first time required when the object was projected. And I have my time of flight, I have my time taken, and the range is given. So from this diagram, I'll be deriving the vertical component and the horizontal component of the projectile. I'll be deriving that. And before I start deriving, now let me quickly explain what do we mean by a projectile. A projectile motion is a motion that moves in a parabolic curve or path. So when we talk about projectile motion, it's also defined as the object launched into the air or transferred into the space and move freely by itself due to influence of gravity. That is, for an object to be projected, gravity is set in place. Please kindly follow as I'll be giving derivation of the two components we have in a projectile motion. If you look at this diagram very well, you can see that we can actually get a right angle triangle from the diagram. Look straight through the origin, the zero I'm having here. We can actually derive through a formula. Alright, from the diagram above, we have a right triangle. You can see the diagram showing Vy, Vxu, and angle theta. So let's make use of SOHCAHTOA. So what's the SOHCAHTOA? A SOHCAHTOA is a trigonometry abbreviation for sine, cos, and tan. So means sine theta. Sine theta equals to opposite over hypotenuse. Likewise, ca means cos theta. That's adjacent over hypotenuse. And toa means tan theta. That's opposite all over adjacent. That is, sin theta will give us Vy all over u. So if I cross multiply, I'm going to have Vy equals to u sin theta. So here is the vertical component of the projectile. Vertical component. Same thing, cos theta will be equals to Vx all over u. So this will give us Vx equals to u cos theta. So this will be the horizontal component of the projectile. So tan theta will be equals to Vy all over Vx. That's opposite over adjacent, and this will actually be equals to, that's u sin theta all over u cos theta. So this is the derivation. So we know this to be a vertical component of projectile. Here is our horizontal component. So let's talk about terms used in solving projectile motion using the equations of motion. So we'll be talking about the four terms used in solving projectile motion. The first one is the time taken. So what's the time taken? Time taken is the time required for a projectile to reach its maximum height. So we can see that from this diagram. So the time taken is the thing we are saying here. So the maximum height the object it was projected to get to its maximum height, that's what we mean by the time taken. And this can be derived using the first equation of motion, which says V equals to U plus AT. That's our first equation. So where V will be 0 meter per second at this point. So Vy, our vertical component, will give us u sin theta